Hello students, welcome to the maths class. Students, today we are going to start a new chapter, that is limits. It is very interesting topic. So let's start with its objectives first. First is introduction of limits. Second, method to find limit of different types of algebraic functions. Third, limit of a trigonometric function. Then fourth is limit of exponential and logarithmic functions. Fifth, that is limit of a function using H method. Students, today we are going to start with the very first objective, that is introduction of limits. Then we will complete the second objective, that is method to find limit of different types of algebraic function. So first is the introduction of limits. Now, a limit of a function is defined as a value where the function reaches as the limit reaches some value. So here we will check the value of function changes as the limit changes. Now here let's try to understand this with the help of example. For example, if we have to find the limit at 2, now we can approach 2 from the both sides, that is from the left hand side and from the right hand side. Now we have to check the behavior of any function as we move towards a particular point from the left hand side or from the right hand side. Now let's take an example. For example, we have to check the limit of this function at x approaches to 2. Now function is x plus 3. Let's take some value in the neighborhood of the 2. For example, we are having 1.9. Now when you put the value here, we will get f of 1.9 is equal to, we will put here 1.9 plus 3 is 4.9. Similarly, if we move more closer to 2, say it is 1.99. Now at 1.99, value will be 1.99 plus 3. So it is 4.99. Similarly, if we take more value, that is f of 1.999, that is again more closer to 2, its value will changes to 4.999. Now, you can see from the values, as we are moving closer to 2 from the left hand side, value of fx, it is all approaches to 5, because these are the nearby values of the 5. In this case, the function behaving, as we move closer to the 2 from the left hand side, its values approaches to 5. Similarly, if we take the value from the right hand side, say it is a value 2.1. Now again check their behavior. Now f of 2.1 is equal to, when you put here, we will get 5.1. Similarly, if it is 2.01, we will take the value, it is 5.01. Again, if we take the value 2.001, answer will be 5.001. Now, again you can see the behavior of the function. As we are moving closer to the point 2 from the right hand side, this is the left hand side, its values again approaching to 5. So this is the behavior of the function as we move to the particular point from the left hand side or from the right hand side. Now, limit help us to analyze the behavior of any function. It may be algebraic or non-algebraic at a particular point. This is the basics related to the limit. Basically, we will check the behavior of any function. Now, let's discuss its different types. First type is algebraic function without denominator. Now, whenever algebraic function is there but no denominator is there, in that case we will do the direct substitution. So here direct substitution of value is there. So it is 1 cube. Here we will put 1 minus 1 square plus 1. On simplifying, it is 1 minus 1 and plus 1. Plus 1 and minus 1 will cancel out. So we are left with 1. So limit x approaches to 1 of x cube minus x square plus 1 is 1. In this way, we can find the limit. Next type is algebraic function in fx upon gx form. It means denominator is there. Now, note that whenever denominator is there, it should not be 0. So, gx is not equal to 0 as x approaches to a, that is at a given limit. Now, let's take an example based on it. So, example number 1, limit x approaches to 4, 4x plus 3 upon x minus 2. Now, in this case, this is a gx denominator. Firstly, you will check the value of denominator. Now, when you put 4 in the denominator, here 4 minus 2 is not equal to 0. So, here we can do the direct substitution. So, when you put the value, what is the answer? You can check it. 4 multiply here x approaches to 4 plus 3 upon 4 minus 2. So, on simplifying, 16 plus 3 upon 2. So, answer is 19 upon 2. Now, let's take the next example where denominator is becoming 0. Now, here limit x approaches to 2, 3x square minus x minus 10 upon x square minus 4. Now, here value of gx is x square minus 4. Now, when you substitute the value of x, here we get 2 square, that is 4 minus 4, so it is 0. Now, whenever denominator is becoming 0, it means we can't apply the limit directly. Direct substitution is not possible. In this case, we will use the factorization method. So, factorize the numerator and denominator. So, here we get 3x plus 5 multiply x minus 2, and in the denominator here we will apply the identity a square minus b square. So, we get x minus 2 multiply x plus 2. Now, as you can see from the question, that is x minus 2 is cancelled out. So, we are left with limit x approaches to 2, 3x plus 5 upon x plus 2. Now, we will do the substitution. So, as x approaches to 2, it is 3 into 2 plus 5 upon 2 plus 2. On simplifying, 6 plus 5 upon 4. So, answer is 11 by 4. This way, you can find the limit of a function when denominator is given. Next is the very special type, that is limit x approaches to a, x raised to power n minus a raised to power n upon x minus a is equal to n into a raised to power n minus 1. Now, what is special about this limit? Now, here you can see as x approaches to a, all the terms are same, xa, xa, xa. Here the terms are with the power and in denominator power is not there. You have to check the point. As x approaches to a, here it should be same term. If it is 2 here, it should be 2. If it is 3 here, it should be 3. Only then we can apply the limit. So, direct formula is n into a raised to power n minus 1. Now, let's do one example based on it so that it is clear to you. For example, evaluate limit x approaches to 2, x raised to power 4 minus 16 upon x minus 2. Now here factorization is also possible, but we can't factorize the higher power. For example, if we are having x raised to power 10, it is not possible for us to factorize the higher power. So we will apply this type. Now here x is approaching to 2. So here it should be same. So we will write 16 as 2 raised to power 4. In the denominator it is already in the form of x minus 2. Now you can see that this type is similar to this form. Now whenever we have to apply the formula, always write it on the right hand side. Now when you compare it with the given form, so you can find a is equal to 2 and this is the value of n. N is equal to 4. By using the result, we get n minus 1, that is 4 into 2 raised to power 4 minus 1. So on simplifying, it is 4 into 2 raised to power 3 and 4 is equal to 8, that is 32. In this way, we can solve the sums by applying the special type. Now students, you are able to solve sums related to these 3 types given in your SNAP homework. Before starting your work, go through the links guided in the SNAP homework. Rest we will continue in our next class. Thank you.